Well, good morning, fifth graders, or actually maybe afternoon for you guys, depending on when you're when you're doing this. So this is today's homework, and this is chapter one, section two, and I want you guys to do pages. Looks like it's 10, 11, and 12. You may not have to do all of the problems. Sometimes I scratch out some problems. But anyways, let's take a look at this here. So the very first page here says, according to the 2010 U.S. Census, the population of Phoenix, Arizona is about 1,440,000. It says, what's the relationship between the value of the two fours in this number? And this lesson is about place value. And I don't know if you guys had been taught place value in fourth grade. Of course, if we were in the classroom, I would just ask you. So I'm not sure. So it says writing the number in expanded form can help. And let's look at each one of these here for a moment before we go any further. Let me show you. This is expanded form, this right here. It's 1 times 1,000,000 plus 4 times 100,000 plus 4 times 10,000. And that's expanded form. Standard form is just the number, okay? And then the number name is just written, 1,444,000. And this is the same thing. They don't really have a form for that, but it says using exponents, this can be written as, and then you've got 1 times 10 to the 6th, plus 4 times 10 to the 5th, plus 4 times 10 to the 4th, okay? So those are going to come into play multiple times in the next few weeks. So make sure you remember what standard form is, what expanded form is, and if they ask you for the number name, you're just handwriting it out. You're just writing out the number. Okay. So what is the difference or the relationship between the two fours there? Well, they kind of answer that question. The difference between the two is times 10. In fact, in place value, if the numbers are the same, so if I was to write a number here like, let's say, 3,333,333, okay? What's the difference between this 3 and this 3? Well, it would be 10. It would be times 10, okay? What's the difference between this 3 here and this 3 here? Well, it'd be times 10. That's the difference. And that's assuming the numbers are the same. That's why I wrote 3,333,333. And so in this particular case, the numbers are the same. They're talking about two fours. If the numbers are different, then it wouldn't be times 10. It might be times something else. So that's the difference when we're talking about place value. And so they've got a chart here for you guys to look at. You can see right here, this is the ones place, the tens, the hundreds, the 1,000ths place, the 10,000ths, 100,000ths, 1,000,000, that's where the 1 is, 10 million, and 100 million. We can keep going in that direction. Right here would be the decimal, and actually we'll be dealing with values that are in these categories too. It'd be the tenths, the hundredths, and the thousandths. It'd be a THS ending on them, but we'll get to that later. So let's look at some other place value charts. I found some, and I'll just show them to you really quick. And I think it would be good for you guys to make your own place value charts. Let's see here. I want to show layer 2. Okay, so look at this top one. Move this out of the way. So here we have the thousandths, the hundredths, tens, ones, and here's where the decimal would go, and the tenths, THS ending, hundredths, THS ending, thousandths, THS ending. Okay. And here's another place value chart. In fact, I've got a couple here you could look at. Millionths in the yellow, hundred thousandths, 10,000ths, thousands, hundreds, tens, ones. Of course, here is where the decimal would go. And then again, the tenths, THS ending, hundredths, thousandths. And then here's another one without any colors. If you don't like colors, if you don't like the rainbow or something like that, well, then you could just make yourself a place value chart like that. Okay. So I really think it would be a good idea for you guys to make your own place value chart and consider doing that. So let me get rid of these here. I don't want to display that anymore. Okay. Oh, that's funny. They wrote my highlighting bled through the the pictures that I had up for you guys. See if I can get rid of those and move this back up. Oh, I'll get rid of those too. I don't know if you can see them on your screen or not. Okay. So let's move this up and take a look. The please convince me, it says, is the value of the 1 in 1,444,000 10 times as great as the value of the 4? Explain. Well, no, it's not. No. And it says explain. Well, a 1 million, and I'm going to write 1 million, that's followed by 6 zeros, is not 10 times, and they're talking about the 4 in the 100,000th place is not, in the 100th is not 10 times 400,000. Okay, remember how I put the 3's up? It has to be the same number for it to be 10 times. Okay. Let's see here. Guided practice. Let's move on to the first page where you guys are going to be doing some work here. They give you another example. I'm not going to worry about that right here, but you could look at it if you want in your book. It says, do you understand, excuse me, in 9,290 is the value of the first 9, that would be this one. Well, actually, I'm assuming it's that one. Maybe they're talking about this one. Is the value of the first 9 10 times as great as the value of the second 9? Well, okay, so this would be the first 9 right here. This would be the second 9. So is the value of the first 9 10 times as great as the value of the second? Explain. Well, again, no, because they're not next to each other. If it was, if the number was, let's say, 999, and the first 9 they're talking about would be this one, the second one is this one. Well, if it just went to this 9 here, if they were talking about that 9, that would be 10 times. Okay, but they're talking about this 9 right here. So actually that would be 100 times. Okay. It does say to explain, well, no, the value of the first is not 10 times the value of the second 9. Okay. All right, number 2 here, it says write 4,050 in expanded form. Okay. So I'm going to do this first one for you here, and I think you're going to have to do others like that. So if you don't remember what expanded form is, flip back a page And you'll see it right here. Here's expanded form. All right. So let's do this first one. So we have 4,050. So that's going to be 4 times 1,000 because it's in the thousandths place. Okay. Plus, there's a 0 there, so we're not going to worry about that 0. I mean, you could write plus 0 times that'd be 100. But what's anything times 0 is what? 0. You guys know that. So we're not going to worry about it. I mean, there'd be no reason to put that down. So we're just going to skip that 0. Just ignore it. And then there's a 5. So that's going to be plus 5 times. What place is the 5 in? The 5 is in the, well, do you remember? What place is that? That's the tens place. So it'd be 5 times, what, 10. Okay. That's expanded form for 4,050. So where there are zeros, you don't have to worry about it. Okay, for 3 and 4, it says write the values of the given digits. Okay, so for number 3 here, the value of the given digits, they're asking for the values of the 7s. So there's a 7,000, and then that's the first one I did. And then the second 7 is, I'll just put a comma, 700. Okay? And then it says write the values of the given digits. So you got to write the values of the 2s. So we're not going to worry about the 5. The first 2 here, what's that value? 20. What's the second value? Or the last 2 here? Well, that's just 2. That's in the ones place. Okay. Okay. I think you guys could do these. That's not too hard here. It says write each number in standard form. Do you remember what standard form is? That's just the number itself. So I'll do the first one for you here. Looks like this is going to be 8,309,000. So I'm going to put 8 million, comma, and then 309. So it's going to be a bunch of zeros, 0, 0, 0, and then 300, and then another 0, and a 9 in the ones place. Okay. Ooh, well, you got to write number 6 in standard form. So what is 10 times, or 10 to the 4th power? 10 to the 4th power. What's that equal? Well, add a 1 and then 4 zeros. What is that? That's 10,000. What's 10 to the 2nd power? What's that equal? That's going to be 1 followed by 2 zeros. So you could look at this, if I was to take this right here and rewrite it, if that would help you guys, it would be 4 times 10,000 plus 6 times 100. How would I write that in standard form? That would be 40,600. Okay. Then 8, 9, and 10, write those in expanded form. So this would be like, let's look at number 10 together here. Expanded form. So it's going to be 8 times, what place is that? The 5 is in the millionths place. The 8 is in the 10 millionths place. So it's going to be 10 followed by 6 zeros. Plus 5 times 1 million. Plus, then all these zeros I'm not going to worry about. Plus 1 times 10. That's going to be that one right there. Plus 1 times 1. That's going to be the last one right there. Okay, I think you can do the rest of these on your own. Let's look at the last page. I got to keep this under 20 minutes. I don't like to keep these videos too long, otherwise I lose you guys. Write the number name oh, there's a key right there, and expanded form for the number of driver ants that could be in 2 colonies. Okay, up to, what is this number here? 22 million driver ants can live in a single colony. And it says 2 colonies. That should tell you something. So we're going to be adding 22 million plus 22 million is 44 million. And so they're asking us to write that number in expanded form and write the number name. Okay? So, well, I kind of already did the number name for you. I wrote it out in number form, but the number name itself would be 44 million. That's the number name. And then in expanded form, well, that's going to be pretty easy because almost all of it is zeros. So it's just going to be 40 million plus 4 million. Okay. Number 15, a queen ant can produce about 9 million ants in her lifetime. Write this number in standard form. Well, you guys can do that. Number 16, Paul says that the number 6,367, in that number, the 6 is 10 times as great as the other 6. Well, are they next to each other? No, they're not. So he's wrong. Is he correct? Well, the answer is no, and explain why. Because the first 6 is not 10 times as great as the second 6. They're 2 places apart. All right? It's this 6 here is 100 times as great as this 6. Okay, so you'll have to write that out. Number 17, what is that, George? Is that how you pronounce that? Drew a square that had a side length of 8 inches. What is the perimeter of George's square? Well, do you guys remember what a perimeter is? Perimeter is what goes around. So here's a square, okay, and actually that's a rectangle. So let me undo that. I'll try to draw a square here. So there's a square, because a square, all sides are equal lengths. That's pretty close. All right, it's good enough for government work. So if this is 8 inches, whoops, take it off that. If this is 8 inches, that means all these are 8 inches. And when we're talking about perimeter, we're talking about what goes around. Okay, we're talking about walking around something. Okay, if here is a swimming pool. Okay, okay, I don't want to do a green. I'm going to do white. Here's a swimming pool, and it's full of water. Okay, and there's a bunch of 8th grade boys that have to be walking around the pool. Okay, here's these 8th grade boys walking around the pool. Okay, and actually I shouldn't have done a round pool. I should have done a square pool to make this work. So it's a square pool. There we go. And they're having to walk around the pool. And if we wanted to figure out how far they're walking, and assuming it's a square, like this one up above, whoops, like this one up above, then you would have to know the length of one of the sides. And of course, in this swimming pool are alligators. Okay, there's the eyeball of an alligator, and here's his mouth. Okay, and he's looking at these 8th grade boys, and here's his teeth. All right, and here's his scale, and there's his tail. So Yeah, if they fall in the pool, then they would get eaten by the alligator. So, okay, shoot. What do we got left here? Anything that you guys need help with? Let me look. Number 18, Dan wrote. Looks like that's expanded form using exponents. What error did he make in expanded form? What's the standard form of the number? So, number 18. Let's see here. Let me write the standard form, and then I think you could probably figure it out. It's going to be 2,350,004. Look and see what error he made. All right? See if you can figure that out. Let's see. Colleen says that she's thinking of a 4-digit number in which all the digits are the same. The value of the digit in the hundredths place is 200. What number is it? Well, if all the digits are the same and the value of the digit in the hundredths place is 200, what are all the digits going to be? And it's a 4-digit number. 2, 2, 2, 2. That's pretty easy, huh? You don't need to explain that. And then describe the relationship between the values of the digits in the number. That you could do. Well, what's the relationship between this 2 and this 2? And this 2 and this 2? And this 2 and this 2? All right, you guys should know that. We've been talking about that. Place value. If the digits are the same, they're times 10 one another. But you'll have to put that in your own words. Okay, that's it. Hopefully this was less than 20 minutes. I'm not sure.